Hello and welcome to this new tutorial for MIDAS Civil. Today we'll talk about the construction stage analysis of a bridge using a composite section. So I will show you how to assign the loads to this composite bridge and how to make the construction stage analysis with it. Next week we will talk about cable stayed bridge analysis, so don't forget to subscribe to the YouTube channel to get the new tutorial every week. First thing I will do is to close this project and open a new window. Now during 1 minute I will talk about the procedure we will follow during this tutorial. So you can download the PDF from her website midasuser.com. The analysis usually for the construction stage is done like that. First you define the material and the section properties, then you define some structure groups, boundary groups and load groups, then you define the construction stages, you activate the boundary group and load groups which correspond to each construction stage, and you activate the floor section which correspond to each construction stage, and finally you can review the results for each construction stage. So this is the cross section of the bridge we will use. So as you see, it is a composite section with steel girders and some slab in concrete material. So girder, the cross beam will be in steel and the slab will be in concrete C6000. Loading will be the dead load before the composite action, the cell weight of the steel girder, and the self weight of the concrete slab, and the dead load after the composite action. And this is the construction stage. So here you have the beam of the bridge and the stage of construction. So during the first stage the steel structure is constructed, and then during the second stage we pose the first part of the concrete slab, and then the other two parts during the stage 3 and 4. So this is the load cases and the load groups, and the boundary conditions, and finally the construction stages. Okay, so let's go in the software and begin to do that. So first of all, we have created a new project. Now for the unit we'll use kilonewton and meter. So if you didn't use this unit, you can still change on this bottom part of the screen. Now we will go into the property tab and enter the material properties. So first click on add in the material tab and choose the steel material. Standard will be ASTMS, and for the first one choose A53 and click on apply to add it to your project. Now we'll just find the A36 material and apply again. And now for the concrete material you have to change the type of material you're using. The standard for concrete is STMRC, and we'll choose grade 6000 and click OK to add the material. Now we'll create the section properties. So go in the section tab and click on. Okay, now let's click on add to add the composite section. So just click on the composite tab, enter the name, then choose the type of the section, still I, enter the coefficient, 2 for the girders, So when you entered all these coefficients, you can click on select the material from the DB, and here select the concrete material and the steel material which is in the section, and click on OK, and these coefficients will be automatically defined. So there's only one thing to change here. The DS divided by DC ratio has to be set to 0. So in fact this coefficient represents the unit weight steel vs the concrete. So the value should be assigned to 0 because we will treat slab weight as a beam load. So we don't want to use the self weight of the concrete. So when you have done that, click on OK to add your section to this. Now we'll create two other sections with the same properties, so you can simply select this and copy it 2 times, then click on modify just to modify the name, so section 2 and section 3. Okay, and add a 4th section from this DB user menu, ID4, choose the I section, click on user defined, and enter the appropriate coefficients. Then click on OK. You have to define the section name, so call it C-beam and click on OK. Now close this window. Now we'll enter time-dependent material properties. So in fact, time-dependent material properties are used to define and to consider the variation in concrete strength, which is led by variations in the model of elasticity of the concrete, also the creep and the drying shrinkage developing with time. So here select creep and shrinkage and click on add, enter name mat1. Here for the compressive strength of the concrete at the age of 20 days we can enter 20,000 for this coefficient. The relative humidity will be 70. The notational size of the member is 0.245. The type of the cement will just use normal. Apply. You can show the result to see the curve of creep, and click on OK to assign it, then close the menu. Placed concrete is hardened and gains strength with age, so to consider this, a function of compressive strength of the concrete is given by the CEB FIP code. The data entered in the time-dependent material dialog box is adopted in the time-dependent material. So you have to choose the time-dependent material and compressive strength dialog box, and here we'll add this in this window. So again, enter name. You can call it also mat1. We'll use the code and we'll use the CEB FIP code. We'll use the same 20,000 for the age of hardening, and redraw graph. So here you have the view of the time-dependent material, the compressive strength. Click on OK and close. Finally, in MIDAS Civil, the time-dependent material is defined separately from the conventional material, and the time-dependent material properties can be assigned to a conventional material selected. So you have to click on material link to assign the dependent material properties to the concrete slab. So here select the material you just created, and in this menu select the concrete material and add it to the selected material. You can add modify and close the window. So we're done with the assignment of the materials and the sections. Next step is to assign the groups, so the structure group, the boundary group, and the load group. To do that, go in the group of the group tab of the 3 menu. Click first on the structure group, right click, click on the second new button, enter a name, so it will be S group, and add it. Now close, so you added one structural group. Now we'll use the same methods to add some boundary groups. So enter name B group, and this time we'll generate we'll add this, and then we'll add another, we'll call it E whites, and this time we'll use the suffix function 1, 2, 3 in order to generate 3 groups at the same time. Click on close. Now let's do the same for the load group. Click on new, and first one will be DLBC group, suffix 1 to 4, add, and DLAC, add, oh sorry, just want to add 1, so I will change the name. Okay, close, and now you added your 5 load groups.